Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Thank you. Upfront, I'll just set the expectations. So this, I know this is a work in progress, so I don't have any results here, but I thought, I'll present this problem because, to generate interest and discussions, because there's a area of interest currently we are looking at. So to provide some context here, so what we are looking at is, trying to solve these enterprise class problems, which are, for example, analytics, whether it's text or video or anything, which are currently very, sometimes very hard for machines to solve them because, the rate of recognition or rate of, the classifier results are very, very bad. So what we are trying to do is to use machine and human computation to trying to solve enterprise problems, for example, in analytics. And there, we use crowdsourcing as well as machine classifiers and combine them to solve this problem. So what is the problem of result aggregation? So what we are doing here is, you assign microtasks to workers as well as machines. So you have this small, if you know Amazon Mechanical Turk, so where you have these small tasks which are called microtasks that you send out to workers. It could be, a simple thing. Most of them are computer vision problems where you say that is there a dog in that picture, or is there, a human being or whatever. And the workers come back with their results saying, saying that, okay, yes or no, or, maybe just simple, some multiple choice answer. And then the problem is that, you need to aggregate those results because the worker could be malicious, they could have bias, or simply they could have, they don't know the answer. So you have these imperfect labels that come from the workers, and also machines, because the machines, you send it to machines, machine classifiers, and the idea is that how do you combine all these results to come up with a joint interpretation of what the label of the task was. So of course you have this whole machine classifier combination paradigm, but the difference here is that the worker, which is the human classifier here, quality cannot be estimated a priori, because most of these workers in the crowdsourcing space, they come for one of your tasks. You don't have long-term relationship with that worker, so you cannot actually estimate a priori the bias and all that you can actually do with a machine classifier whom you have trained with some data. Human worker quality is not consistent, so what they may do in the morning may be different in the evening, and so on. So there's a variation that happens in the quality, and that's why you need to monitor them and part. So that's really the difference why you cannot directly pick up all the classifier combination paradigm and put it here, because the worker quality varies with time, and you need to estimate the worker quality as you go aggregating the result. So just a brief background. So what people have done. So of course simple majority vote is something that people have used and still being used very, very frequently. But one of the problem here is in a paper by Sheng. So if you see if the worker quality here, which is denoted by P, if it falls below 0.5, then if you have a pool of worker and you do a majority vote, actually your quality of your majority vote actually goes down with the number of with the increased number of labelers. So majority vote may not be a good idea when you have workers who are not of good quality, or people may be adversarial. So people have also tried weighted majority vote, which again is a very natural thing to try because of the classifier combination. You have this weighted class. So again, the problem is that you cannot use all the theory of classifier combination there because you don't know the worker quality there. So what can we do better when you don't when the worker quality cannot be estimated a priori. So what people have done, and there are a lot of platforms currently, for example, Crowdflower and so on, what they do is that they insert what is called golden data in real time along with the tasks. So there are tasks for which you don't know the labels, but in between you insert tasks for which you know the label, and you can actually monitor the quality of the worker and use that worker quality to actually do a weighted majority voting as in classifier combination. And you can also discard low quality workers because obviously sending it to a bad worker is waste of money. But the most popular ones, which are, they have been found in a lot of the recent literature, is this whole EM-based approach, where basically what you are trying to do is that, so you have these labels that you have for a microtask, you have labels from the workers. You have the ground truth, which is the node Z1 and Z1, Z2, and you have the worker quality P1 and P2s for the two workers. And so so you have this model where you have the label, which is children of the ground truth, which is the label that you are trying to determine, and the worker quality, and both of these are unobserved hidden nodes, whereas this is the only thing that you observe. So the most natural thing to do is to use an EM approach where you estimate the confusion matrix, which is the worker quality on the estimated ground truth, and then use that to actually recompute the maximum likelihood estimate of the ground truth and so on. And that's exactly what Srijana described in the earlier talk. So now the problem is that in all of this there's a problem of this worker EM. Of course, you know that you can get stuck in a local minima. So now the problem is, now can you rely on the solution that you have from this EM algorithm, and can you now, some of these things that still need to solve is that, can you make the model richer using the task difficulty or worker bias, because that's what also decides. If you have a task which is more difficult, obviously the results would be much more noisy, or if the worker has a bias, again it will affect these labels. So can you make these models more richer and try to estimate the ground truth based on that? So some of the research challenges are, so if you try to aggregate these results from different workers, one of the problems is that these data types are very different. For example, if you ask somebody to label that, label all the cars on the highway, you have this kind of bounding boxes of the face. But if you ask somebody that what is the trajectory of this person in the video, these are lines like this. So how do you combine these different, or if you have something which is more of a text classification, you have confidence scores, which are basically just saying these are the label, and so how do you use these different data types and have a single framework by which you can actually combine all these different labels. So again, aggregating, so in our framework we're not just talking about human classification, but human and machine. So human classification will lead to output which is of a different kind, which is maybe their confidence, their bias, and so on. And machine output may be of a completely different type, because so how do you combine, and they are on completely different type of the confidence score from a machine and from a human may not make sense to be just combined blindly. So how do you combine the machine results and the human results into in a single paradigm? How do you do iterative partial result aggregation? So in a crowdsourcing scenario, you're not going to get result, you send out in a batch and you're not going to get the same batch back at the same moment of time. So how do you you are going to get few results at a time. So how do you combine iteratively these results and make sure that once you've got all the results back, in a global sense, you are doing as good as getting all the results back if you had got all of them back in a batch. We would also like to model the aspect of risk in a task. For example, using the task completion time or the task pickup time, so where you have the model of a traffic of the the work being picked up. So how do you use some of the ideas of queuing theory to actually compute risk on these tasks, and model also model the worker capability and the task difficulty in our framework, and also compute the risk of so if I want, for example, in an enterprise, so in an enterprise problem, you'd like to compute the risk of this task being completed. If you give an enterprise an SLA, the enterprise is going to say, this is the work I want to get completed with this accuracy in this time and with this budget. So how do you make sure that you are able to compute the risk that this work will be completed in some time and with some level of accuracy? So that's all I had. So would be very happy if you if there's any feedback or comment or any ideas you have. Thank you.